Hello, everybody around the globe. Today, I'm going to introduce one of my favorite repositories called EasyDBMigrator, available on my GitHub and also on the Get It package manager. My name is Ali, an Embarcadero MVP, and I've been a Delphi developer for around 15 years. You can find my content and connect with me on GitHub, YouTube, and LinkedIn. In this presentation, I will clarify what this library is and isn't, discuss its usefulness, explain how to use it, and present additional concepts. Finally, I will demonstrate some real-world examples in action. EasyDBMigrator is a library for database evolution and migration, specifically designed for Delphi. It simplifies database evolution and is available in both 32-bit and 64-bit versions. It is not an ORM, but it will utilize one either internally or externally. In this library's culture, migrations are structured objects that modify the database schema, offering a streamlined alternative to manually executing multiple SQL scripts by every developer. These migrations encapsulate changes in a coherent format, enabling developers to version control the database schema alongside application code. Each migration file serves as a historical record, documenting the evolution of the database structure over time. This ensures not only consistency across different environments, but also facilitates collaboration among team members who may be working on different features concurrently. When running migrations, the library system maintains a tracking table that logs which migrations have been applied, preventing redundancy and conflicts. Developers can create, modify, or roll back migrations with simple commands, which abstracts away the complexity of raw SQL statements. This approach not only saves time, but also minimizes the risk of introducing errors that can arise from manual execution. By adhering to this structured migration process, the development team can confidently move forward with new features, knowing that the database schema will always align with the application's requirements. Furthermore, this practice fosters a culture of accountability, as each migration is authored and reviewed, ensuring that all changes are intentional and thoroughly vetted before being integrated into the shared codebase. It is easier to manage some versioned Delphi classes instead of thousands of lines of script. It is possible to document everything about the database structure in XML document format, inline comments, etc. It is possible to manage database schema versioning upgrades and downgrades. It can be safer than a script file because it's integrated internally into exe, while if your old script file falls into the hands of people who shouldn't, the entire structure of your database will be exposed. When dealing with multiple databases such as the developer's local database, test or production database, migrations are a helpful solution for evolving a database schema. These changes to the schema are recorded in Delphi classes which can then be committed to a version control system. It is extremely easy for newcomers to the company to be onboarded about the database structure. Multiple databases are covered, like Microsoft SQL Server, MySQL, MariaDB, PostgreSQL, and Oracle. Multiple Delphi versions are supported by Delphi XE5 to the latest version Delphi 12.1 Athens at the time of recording this video in 2024. To use the library, simply incorporate the units into your projects, implement migrations, and execute the runner. It's that simple. There are various kinds of samples available. Simple, suitable for small projects, using on-demand classes with anonymous methods. Advanced, suitable for large projects, using versioned classes with attributes. Instead of creating some on-demand classes, you can create one unit per entity and implement versioned classes over time. ORM, suitable for both small and large projects. Large script. This is a script executor that allows you to use your existing old script as a starting point and continue working with this library from that point. Does this library have any underlying dependencies? Well, the short answer is no, but please be aware, to work with certain database engines such as MySQL, libmysql 32al, or PostgreSQL, lipq.del. You will need to have the appropriate DEL. There are no other prerequisite libraries or components required. It is important to ensure that you provide the correct DEL or class library depending on the specific version of the database engine installed in your environment. Please note that this library does not include the necessary DLs, but rather provides a template for each database engine. Note: a condition definition has been added to provide additional features, such as additional overridden constructors and functions. This is to prevent compiler prompts and hints for unused functions. If you want access to all functionalities, you can use full options as a conditional definition of your project.
I have a large script called the AdventureWorks creation script, containing over 7,000 lines. As you can imagine, it can be quite overwhelming for new employees to understand and navigate, unless they have been with the company for a long time. Debugging and tracing the script can also be difficult, as there is often no documentation provided. I highly recommend checking out this library and its concepts. Integrating it into your project can lead to impressive results. To making something clear, traceable, documentable, and easier to maintain and control is crucial. To simplify this process, EasyDBMigrator, also known as EasyDB, can help to make things more organized and efficient. Now, I have a test database here. Let me check if it's empty or not. Yeah, it appears to be empty. Let's go and try to create some entities of this database using the library instead of DirectScript or Management Studio. First, I open the simple project that doesn't need separate units and classes. Instead of that, you will create some classes on the fly with 2 anonymous methods for upgrade and downgrade. To do the job, there are 3 steps to follow. The first step is initialization, which involves obtaining the connection string, establishing the database connection, and creating other necessary objects. Upon initial connection to the database, a table called EasyDBInfo will be automatically created. This table is responsible for keeping track of versioning information for the library and database. Here we have a connection param, which is a record. This is available for each database engine and has different record members depending on the target's connection string, such as T-SQL connection params, MySQL connection params, and more. Since it is a record, there is no need to create and free it. Then you should initialize another object called runner and define it in the private section of the current forms class. And there is an event called onLog. This event will provide some info when fires. I use them in this memo, here as you can see the code. You can use this information in various ways, such as sending it via Telegram, email, cloud notification services, and more. Once the connection is established, EasyDB will attempt to create the versioning information table or retrieve the latest applied version from an existing table. Next, you have the option to configure additional settings, though they are not required. However, I highly recommend using the Use Internal Thread option to prevent your application from becoming locked. Let me quickly explain some options. Enabling the Log All Executions setting will log all executions for each activity and transaction, while the false setting will only log when there is an exception. Additionally, the internal thread option utilizes an anonymous thread for improved performance and a better user interface experience, such as displaying a progress bar by adjusting the related configuration. Lastly, the delayed execution option is used solely for testing purposes and is only being used here to demonstrate progress. By utilizing the addLogger function and assigning an event, you can activate the internal logger. Including a log event is not required, but if you wish to display information to the user, it is recommended to define a callback event. Moreover, consider this commented line here. If you use it in this way, you will have a text file including log messages. I don't need a text file, so I commented this line for now. The next step involves adding the necessary migrations. Before anything else, it is necessary to clear the runner. You can add 1 migration at a time. As an example, I have 4 migrations here. Note that, we have a tMigration class that actually is that structured object that will manage upgrade or downgrade of each version. The constructor for this class requires several parameters to provide versioning information, including the entity name and a flexible big int database version that can accommodate different formats. The version number is generated using a combination of date and time. Additionally, the author or developer name and a description, which could include a link to a Jira task or task number in another issue tracker, must be specified. Finally, two anonymous methods must be specified, an up method for upgrading and a down method for downgrading operations. For this example, we are utilizing an exact TSQL script to be executed as an ad hoc query. For version 1 of our sample, we will create a table in the upgrade method and drop it in the downgrade method, as expected. The table will be modified and a new field added with the use of version 2, while version 3 will create a new table and add an additional field. At runtime, this library checks versions and performs required updates. Let me run this sample and observe how it works in action. At this moment it has just created the versioning table. If you refresh the list, you will see that a new table called EasyDB version info has been added. What fields are present in this table? Version, date of apply, the author who has added upgrade methods, or let's say the developer who has done the task, and a description field also has been added. Now I click on this button, Add a Migration. As you know, after this upgrade we expect a table called TB users added in version 1, a new field 2 in version 2, a new field 3, and TB customers in version 3 must be created. As you can see, all expectations have been met and new entities are now ready to be used. Please take note that in version 3, we underwent 2 migrations. As a result, the log now includes descriptions and authors for both migrations. Well, what about the downgrade? What will happen if I want to revert to version 2 or 1? Downgrade methods will happen one by one and version by version downgrade the database. TB customers must be removed, new field 3, new field 2 and so on. Now I reverted everything to version 1. The mentioned version will be retained while any larger versions will be removed and downgraded. For instance, version 1 will be kept while all other versions will be removed. That's all there is to it. This was the basic usage of this library, quick and easy, but it is more suitable for small projects. For larger projects, it can become challenging to maintain clarity and organization. To tackle bigger projects, I recommend using the advanced mode. The second project in the project group is an advanced sample for SQL Server. In this project, there is a folder called Migrations which contains a unit for each entity. This is a significant difference compared to the simple usage approach, as adding migrations is also done differently. Let's open one of them, such as the TB users. We have several version classes that inherit from a class called tMigrationX. However, the simple sample is utilizing a different class called tMigration. tMigrationX utilizes a class-level attribute to gather information on various versions. When creating a new class, it is important to include an attribute called tCustomAttribute for versioning information. Additionally, the class should have two procedures for upgrading and downgrading that override the abstract method of the parent class. Please be aware that I have included the version number in the names of the classes. To upgrade, we'll be using the same table creation script that's used in simple mode. We have a helper object defined in a helper unit that provides an instance of the SQL connection class. This class is a singleton and is helpful for executing scripts. Actually, the queries that will be executed later will utilize this connection object. This object contains various methods for executing scripts. For my example, the first version creates a table, version 2 adds field 2, and version 3 adds field 3. Other units such as invoice have their own versions of classes. The same goes for the customers unit. This approach makes it easy to implement, maintain, and document different units. In this initialization, we follow the same process as the simple mode. However, there is a slight difference when it comes to adding migrations to the runner's migration list. You can either use the modern or classic style, depending on what works best for you and your coding preferences. Personally, I find the modern way easier. Whenever a new migration is added, simply place it in the appropriate location or use the classic method if you prefer. This structure is extremely clean and ready for further development. You can add inline comments, XML comments, or create a full history of this entity and dependencies of this table. This is very useful for new developers to avoid mistakes. Let me empty the database. Same as simple mode, you should initialize, add migrations, and run the migrator using the runner object. Now I refresh the database side, and as you can see, we have our entities. And regarding downgrade, let's say we want to downgrade to version 2, so the field image link based on our structure in version 3 will be removed. For other databases, refer to the relevant sample. The structure is the same, template is the same, but the syntax could be different. Let me finish this video here, and I will explain about the ORM sample in the next video. The third project in the project group is a SQL Server ORM sample. ORM samples are currently available for SQL Server, MySQL, and MariaDB, and for other databases, you can use any other ORM and integrate it into this library easily. Let's have a look at the code and structure of this sample. Well, same as simple and advanced mode, you need to do initialization first. I didn't write it in the form create event because I wanted to create a database in this sample too. If you remember from other videos, we just created some tables so far. Take note that when you are going to create a database, you must connect to the master database first, create your new database, and close the connection. Then you have to reopen a connection that connects to your database to be ready for DDL operations. To create a database with this library you need to do initialization, but consider the database name that should be master in SQL Server. Then you must create a runner and an ORM object. You must assign ORM to runner 2. Now, this mini ORM is able to generate DDL scripts based on your codes here. It will create the database, and free the local runner here. In the second step, when I'm going to add migrations first, I connect to my new database with another initialization process and different connection parameters. Let me drop my test database and let's go and see how it works. Oops, I had breakpoints here. Done, and the result is certainly a new database that is empty. Then I add migrations and upgrade details. If I refresh the database, we should see new tables and fields. As I told you before, you are not forced to use internal ORM. You can easily replace it with any others, and here in this command, submit changes, you can define your own builder object which is responsible for generating scripts. Here are my new entities. Let me show you migrations in ORM format. You need an ORM object that is assigned to the runner. Now the ORM is able to generate scripts. Please check the code regarding ORM usage. To create the database with this library you need to do initialization, but consider the database name that should be master in SQL Server. Then you must create a runner and an ORM object. You must assign ORM to runner 2. Now, this mini ORM is able to generate DDL scripts based on your codes here.